You Today we are gonna do two-way ANOVA in SPSS using a research data on satisfaction levels and the impact of gender and work location on it. So this is a research data, and through this live project, we are gonna conduct two-way ANOVA. We are gonna check the different statistics that are there, their significance levels, and we're gonna do the final interpretation if the ANOVA is giving us some significant interaction values or not. So as you might know, ANOVA is used when we have to compare means of two or more groups. Two-way ANOVA is used when there are more than one independent variable, specifically two IVs. We can have as many as dependent variables, but the IVs should be more than one. And that's when we use two-way ANOVA. Definitely, we'll be having two or more than two groups. So let's get started with the SPSS. Okay, this is our SPSS data. As you can see, there are different respondent IDs, and we have around 872 participants research data here. This is the gender of the participant coded as 0 and 1. And this is the work location of the participant coded as 0 and 1, representing either the central offices or local administrative offices in 0 and 1. Okay, so that is because the independent variables in ANOVA has to be categorical. They cannot be continuous. Now here we have our dependent variables. These are satisfaction levels in different areas such as self-actualizations, belonging, psychological safety, otherwise. So these are five variables. When we have five dependent variables, we'll have to do MANOVA, but today we are not going to do that. We'll just focus on one variable. So we'll use PN and we'll check the impact of work location and gender on this satisfaction level using two-way ANOVA. We'll be covering the analysis for all of these five variables together in the next video using MANOVA. First, we'll go to analyze general linear model, Univariate. We'll pick our DVs here, which is PN. In fixed factor, we'll put our independent variables, which is gender and work location. We will go to options and select descriptive statistics, effect size, and homogeneity test, which are required to check the assumptions of ANOVA if it is fulfilled by the data or not. If the assumptions are not fulfilled, then we cannot do ANOVA or we'll have to do non-parametric test otherwise. Then we'll go to plots and we will create plots interaction plot also here, which will again tell us if there is any interaction between these two factors. So in ANOVA, as you might know, we don't only look at the differences of means in different groups like independent variable 1 and independent variable 2, but we also look at if one IV is affecting the impact of independent variable 2, if there is an interaction factor or not. This plot will help us look at that. We'll click OK and we'll go to our analysis. Now we're going to look at the data and see what are significant values here or not. As you can see here that there are four groups from the combinations of two groups of gender and two groups of work location, and the sample size is different in everyone. So that is an important thing to consider in research because our sample size is different. It can impact our research conclusions. We will move forward with descriptive statistics. We have a basic understanding of the means here, which are close by around 3 and 4, and the n is different, so that might again impact the results. Then we go to Levene's test for homogeneity assumptions. In ANOVA, we assume that the variances of different groups of samples have same variance, homogeneity is there. And Levene's test checks that. So if you see that the value, significance value for all the Levene statistics is 0.4 or 0.3, which is significantly higher than our significant levels of 0.05 or 0.01. So we can say that Levene's test statistic is not significant here. And when it is not significant, our null hypothesis remains, which means that there is no significant difference in the homogeneity of different groups, in the variances of different groups. So our assumption is settled here. We can go ahead to the next part of our analysis and interpretation of the data. Now we go to test of between subject effects. We have our two groups here, and the third statistics is on the interaction of our two independent variables. We'll look at one by one. So for gender, you can see that the significance value is 0.970, which is way higher than 0.05 and 0.01 levels. So this is completely insignificant, and we can say that gender has no significant impact on the scores of satisfaction levels among employees. It is not affecting much, not contributing much to the differences in scores. Then we go to the next factor, which is work location, and we can see that the significance value is 0.169, which is significantly higher than 0.01 and 0.05 significance level. So again, we can interpret that work location also has no significant contribution or impact, or does not significantly influence the scores of satisfaction among employees. Now, the third factor is the interaction of independent variable 1 and IV2, which is gender and work location. We check whether through the interaction of these two variables, there is an impact on the scores of satisfaction level. And as we see, the significance level is 0.89 here, which is way higher than 0.05 and 0.01. So we can say that just like how gender and work location independently are not impacting satisfaction scores, similarly, their interaction is also not impacting satisfaction scores significantly. So our null hypothesis remains intact. Now in this plot, we can check if there is a significant interaction impact from the interaction of work location and gender. On the horizontal axis, we have work location, and on the vertical axis, we have mean scores of satisfaction levels. And the blue and the green line shows two components of gender, that is 0 and 1, male and female. Now, one thing we can notice in the graph is that all these groups are clustered very together. Like, there is no lot of difference. So for both the lines, we can say that both the lines are representing same kind of impact. So either they are having significant effect or insignificant, which we have already seen is not significant in the analysis. Also, if you look at the slope of these two lines, you can see that they're almost vertical. The inclination is almost similar. So the kind of impact they're having is almost similar. And when lines are parallel, the interaction effect is very small. So in this case, the interaction is very small. And we have seen that in ANOVA analysis that it is insignificant. Okay, so throughout our analysis, we can come to this conclusion that our null hypothesis remains and there was no significant mean difference was found in the groups through either of IVs or their interaction. Now, if we go back to our data, we can see that there was no significant impact of independent variable 1 and 2 on PN. That is one of our dependent variables, but we have 4 more dependent variables. Now we can do the same kind of analysis for SN, BN, EN, and SAN for all of the dependent variables one by one, but that would take a lot of time. So to resolve that issue, what we do is we use MANOVA, and that is something I'm going to show in the next video. Thanks a lot for watching this video. I hope it was helpful, and stay tuned for the next video on MANOVA and doing these analysis of 5 DVs in a very short manner.